Hey everybody. Unfortunately, I came down with COVID, so I'm not able to be with you there at DjangCon, and so I'm having to share this presentation, excuse me, with you as a recording instead. So I'll apologize ahead of time if I have to stop and cough during the presentation. My name is Paul, and I'm with a company called Platform.sh. We are a platform as a service enterprise grade secure platform as a service provider that handles the complexities of cloud infrastructure and cloud infrastructure automation so that your development teams can spend more time responding to the changing needs of your organizations. So whether it's one site or 1,000 across any kind of runtime, we can help you maintain standards, security, and compliance across all of them. Now, I mention this because this is going to come back up later in the presentation. Specifically, though, what I want to talk about today is you're building your first GitHub action. Now, in my presentations, I usually like to give a collection of warnings. So if you're listening in, I have an animation of red light flashing to kind of give you a heads up. A couple of warnings before we get started. First is that I am not a GitHub Actions expert. However, that said, I have spent the last 18 months managing, maintaining, and building a collection of workflows and GitHub Actions to support various areas inside of our organization. And during that time, came across a lot of frustrating aspects of learning GitHub Actions. And so my hope is, or it's kind of what spawned this presentation, my hope is to help you navigate around those areas of frustration and kind of jumpstart you on your way to building those GitHub Actions. Now, this presentation is more technical than some of my other ones. I do, however, try to temper that with lots of explanations. So even if you don't understand the specifics, you should be able to get kind of the bigger picture. And last, with anything technical, especially in programming and development, there are 100 different ways to get from point A to point B. So what I'm going to show you might not be the best way for your organization, might not even be the right way. But again, giving that big picture and an understanding of how these key concepts and pieces fit together. So specifically, what I want to go over today, I want to talk about what GitHub Actions is, and I want to begin to talk about the components of the GitHub Actions that you'll use inside this platform to begin to build out your automation. We'll then dive into one of those components called the workflow, and begin talking about its required pieces. We'll then build our first workflow, excuse me, and talk about the components of a custom action, then build our first custom action together, and along the way, talk about caveats and gotchas. And then at the very end, kind of how we can put it all together into something more tangible, something you might be able to use right away. So what is GitHub Actions? Well, GitHub Actions is actually a service. It's a continuous integration and continuous delivery platform that allows you to automate all the pieces surrounding your code base, whether that be automated testing or building or deploying, but everything kind of surrounding that code base. So what are the pieces of GitHub Actions, that platform that you're going to use? Well, we have things like workflows, events, runners, job steps, and GitHub Actions with a little a. So if you're listening in, I've got an animation of Jim Halpert from The Office saying, "Wait, what?" Yeah, so we got GitHub Actions with a big A is the service, is the CI/CD service. GitHub Actions with a little a are individualized, modular, self-contained pieces of automation that we can use in different ways to build out more complicated automations. So I've got another little warning here, and that is that the way that GitHub Actions, the platform, has named things can be very frustrating, confusing. They take a word, excuse me, and then depending on where it's used can have different meanings. So we got GitHub Actions with big A and GitHub Actions with little a. Another one you might come across is status versus checks versus status checks, which are three completely different things, which caused me to have this exasperated sigh, this kind of what? So just be aware that as you're going through the documentation, if you come across something where you've seen it, excuse me, you've read about it and it's not working the way that you just read about it in the documentation, you might have come across one of these scenarios. So again, we've got these different components that we're going to use, and how do they kind of work together? Well, we configure the GitHub Actions platform in a workflow. That workflow is then going to be triggered by one or more events that occur that then run one or more jobs on a runner, where each of those jobs include a series of steps, where each step can then call a script or a shell command or an action. So let's kind of talk about each of these pieces. So the workflow is kind of your main workhorse, excuse me. It is a YAML file, and it must live inside of a workflows directory that sits inside of a .github directory that sits at the root of your repository. Now, a repository can have multiple workflow files, each one triggered by a different event or a same event. But each of these are going to be kind of the main area that you configure your automation. An event then is simply some activity that occurs to or on or with your repository that is used to trigger that workflow. In fact, sometimes in the documentation, they are referred to as workflow triggers and not events, but we do have a large collection of them. So I'm going to hop over here. You can see, this is the documentation for events. You can see we have a large collection of events here on the right that we can pick from to give you fine-grained control over exactly when your workflow will fire. A job then is a series of steps that we define inside that workflow that are going to run. Each of them will run on a runner, and they're going to, and where we designate that runner by the runs on property. Now, by default, your jobs are going to run in parallel. If needed, though, we do have the ability to chain them or build dependencies, but you have to remember that even though you can have an unlimited number of jobs, they are going to run in parallel. And I do have a little asterisk next to unlimited. Depending on your plan of either your personal account or your organizational account and the way you've configured things, there are some limitations. God, I can't talk. Excuse me. But we'll just skip that part. Sorry. A runner then is a server instance where your job is going to run. GitHub does provide several public runners that you can utilize. If you choose to utilize those, you can choose from macOS, Windows, and Ubuntu in various versions. Do note that if you use the public runner, sometimes you do have to wait for them, which is why they give you the option to self-host your runners if you need more dedicated or specifics inside those runner environments. A step then is a collection of things you want to happen inside of a job. These are typically either a shell script or a shell command that you're going to run, or you can access an action that we talked about earlier for that step. They are executed in order and dependent on each other. So if a step fails, it'll fail out the rest of those steps. Again, we have the ability to work around that or change that behavior, but that's how it is by default. And it's important to remember that all steps in a job are executed on the same runner. So they will have access to the same same workspace and file system. An action, as I alluded to earlier, it's a self-contained modular piece of automation that we can chain together in different ways to build out more complex automation tasks. So now I want to go into one of those components, the workflow, since that is our main workhorse. It's where we're going to be building most of this automation and talk about some of the required pieces there. Excuse me. So a workflow must contain at least one event that designates when this workflow will be triggered. It also has to contain one or more jobs that are going to execute on that runner machine. And then it has to have one or more steps defined that are going to run inside of that job. So what I want to do now is build out our first workflow. So I'm going to hop over to my IDE here. So we know we have to have an event. So we're going to use the on keyword. And I will note that I am using a plugin for my IDE that helps me build these workflows. So I'm going to use the workflow dispatch event. This event allows us to manually run our workflow, so I don't have to go in and artificially create, like a pull request, open the pull request, and close it back and forth. The next thing we have to define is a job. So we're going to have the jobs key. We have to define at least one job. So I'm going to call it say hello. We then have to designate at a minimum where this thing is going to run on. So I'm going to choose Ubuntu latest. I can't type either. Ubuntu latest. There we go. And then we have to designate at least one step. In this case, I'm going to designate to run on a shell prompt, and I'm going to do echo hello there. And that is our first workflow. So we come back. Let's make sure these match up. So we have to have an event. That is that workflow dispatch. We have to have a job. Let's say hello. We have to have a runner, which is going to be on Ubuntu latest. Then we have to have at least one step, which is going to be echo hello there. So now if we want to go see this work, you can see these out on my GitHub profile. So you go to github.com/Gilzow. It's pinned up here at the top. And then we should have an Actions tab. This first one that we're running is under .github workflows first. When you designate a workflow dispatch, you'll have this nice little run workflow. I'm going to go ahead and look at a previous run, just so we don't have to wait around for a public runner. Here's my say hello job. If I'd had multiple jobs, they'd all be listed out. And inside there, I can see it was setting it up, and then it ran that hello there. So let's dive deeper into some of these workflow components. So you might have noticed that I created a job ID inside of that job's property. Job IDs have to be a string. They must be unique inside the workflow. So they can be repeated between workflows, but inside the same workflow, they have to be unique. They must start with a letter or an underscore, and they can only contain alphanumeric characters, dashes, or underscores. And again, you have to have at least one step. Your step then is simply an array of tasks. If you feel familiar with the terminal command, the terminal session, which you probably are, each step is going to run in its own terminal session, though it does have access to the workspace and file system. So if a step writes to a file, a further step will be able to still have access to that same file. You're never going to have a situation where a second or a third step or somewhere down the line is going to run in a different runner. They're all going to be on that same runner. Each step then has to include the keywords either uses to designate to the GitHub Actions platform that it's going to use a GitHub action, or the run property, which is going to designate that it's going to run a command line, either binary or some shell script. So let's take a look at our second one. In this case, again, I'm still using on workflow dispatch. I've still got my say hello job. I'm still running on Ubuntu latest, and now I've got 4 steps. So the first one is I'm echoing out again. The second step, in this case, I'm going to use an action called checkout, then running another one, and then a 4th step. Do note, though, that I've added some name properties. What this does is allows you to give a more human-friendly version to output inside that actions area on GitHub. So I've given the workflow a name, I've given the job a name, and I've given the 3rd step a name. And if we come back out, oops, and I just went to all my other, there we go. If we come back out to my actions tab here, I can now see that instead of it being GitHub workflow second, it's welcome to the party. If I go into a run of this workflow, instead of say underscore hello that ID, I got let's greet the user. And now I can see that that 3rd step now displays the name of the step instead of just what it's doing. All right, now, before I go on, you might be asking yourself, all right, the presentation's about GitHub Actions and building a custom action. And for at least 15 of the 45 minutes, I've talked about workflows. So you may be asking yourself, all right, why are you talking about workflows if we're supposed to be building custom actions? Well, the first is that you cannot run a custom action without a workflow. You have to have a workflow to call the action. The second is that a lot of the things that we can do in a workflow, particularly with the workflow dispatch event, very closely mimic what we can do in a custom action, such as inputs. So at some point, your action is probably going to need to be able to ingest or receive data in order to perform that automation. So every action has the ability to accept inputs. Inside of workflows with the workflow dispatch, the workflow call event, we can also accept inputs. Each input has to have an ID, just like the jobs, which also have to be unique, alphanumeric dashes or underscores. For actions inside of that input that we define, we have to have a description property. In addition, you can also designate whether an input is required. You can also set up default values in case they do not provide a value. So let's jump out here. Take a look at my 3rd workflow. So again, same thing, workflow dispatch, job say hello. I've still got the name property. And this time though, I've defined an inputs property where I've given a new input, the key or the ID of the name, added to the description property. It's important to note, I forgot to mention this, that all actions, the type is always going to be a string for actions. For workflow dispatch events, for a workflow, we have several different types, but for actions, every input is going to be a string. And here I've designated that it's true. Now my step is simply to say hello there and then call the value that's been handed in. So if we come back out and we take a look at this action run, which I believe it's hidden. This time I'll show you this. So again, if we have that workflow dispatch, I can run the workflow and notice now because I've defined an input, it's going to show me that input. If I try to run the workflow because it's designated as required, it's going to say, hey, you have to do this. So I'm going to say, this is going to be DjangCon. I'll run that workflow. Now it does take a second because again, we're using those public runners. I'll know it's running once we get a new line at the top. There it goes. Got a little dot. I can now dig into that. It is now setting up our let's greet the user job. There it's completed, and I can see it has output DjangCon. All right. Context, the other piece that we share similarity between workflows with workflow dispatch and custom actions. Context is how the GitHub Actions platform shares data with our scripts and our workflows and actions. It provides access, provides information about the workflow runs, jobs, the runner, steps, inputs, etc. They're exposed to our code as objects contain properties, and those properties either strings or further objects. We do have 12 types of context that we can utilize. Here you can see these: the GitHub, environment, vars, secrets, jobs, runners, strategies, etc. It is important to note that you might not have access to every context. So for example, there's something called a matrix that you can access. If you're not running inside of a matrix, then it makes sense that you wouldn't have access to that particular context. To access a context for your custom actions, as long as they're not JavaScript custom actions, you access it with a $, 2 curly braces, with the context name, dot, and the property you want to access, and then 2 ending curly braces. So in this example I showed you earlier, we have that inputs dot the input name, or in the case of steps, I might do steps, the step ID, its outputs, and then the output ID. If you happen to be building a JavaScript-based custom action, you can utilize the GitHub Actions package, which then exposes these contexts via a method. Quick warning about these, that not all of the not all of the values in the context are prepared for you to utilize inside your code directly. As an example, if I were to try to create a shell variable where I have a double quote and then I put the context ending double quote, such as pull request title, since that comes from the user could do a and then an end double quote and then a semicolon, which means I would end up with double quote a ending double quote semicolon, and then this would then run as just a regular command. So these inputs are kind of ripe for script injections, whether maliciously or inadvertently. So just be aware that you're going to have to prep these for use in your code. All right, if we have inputs, then at some point we might need to output information. This is simply data or information from a step, whether that's an action or, whether that's an action being called as a step or a step directly in a workflow. We need to be able to provide that information back to further steps that may need to utilize that information. To set an output in anything that isn't a JavaScript-based custom action, we'll do a shell command of echo where we set the output ID equal to the value, and then we send that out to the environmental variable GitHub output. Inside of a JavaScript-based custom action, we have, again, another method for using that package of .set output. Then, as I showed you earlier, to use that output, we call the particular context, in this case, is probably a step, that step ID, its outputs object, and the output ID that we've set. So we'll take a quick look here. So in this case, I've got an input. Again, same thing as earlier that I showed you. Down in our steps, this time as the second step, we're going to grab the current time from the date binary or the date command inside of our shell, where they're going to store that value as an ID of current time. And then the last step, we're going to call the steps context, which comes back up, says go get the step called get time. So there's mine with get time. Then go to its outputs object, and then grab the output ID of current time. So if we come back over, oops, where's my, there we go. Here, let's see, this, grab the current time. So again, we're setting that current time to the value of date, setting into the GitHub output environmental variable. And then in that last step, accessing that value via the steps property and the output. All right, so now we're ready to actually build out our custom actions. Oh, wait, not custom action with big A, but custom action, remember, with a little a. All right, so we have three types of custom actions. We have Docker, JavaScript, Composite. Docker is nice in that you can either call a Docker image in a public image repository, or you include a Docker file, and GitHub Actions will build that container for you. These are very good if you have specific requirements for the environment that your action needs to run in. You can also build a JavaScript-based custom action. This is particularly nice because you can kind of compartmentalize your code away from the environment that it's running in and kind of have it self-contained. Composite's interesting because you can actually utilize other actions inside of your action, again, to build up these more complex automation tasks, but expose that overall action as a single action. You can store your actions in one of two locations. You can either store it in a repository all by itself, or you can store it in a directory inside of an existing repository where it's going to be utilized. Now, there are some things that actions have to have. The big piece is that all actions must have an action metadata file. It has to be named action, and it has to be a YAML file. And it has to be stored inside the root of where the action is being stored. So if it's in a repository all by itself, it has to be in the root of the repository. If you're storing it in a directory inside of an existing repository, it has to be in the root of the repository. The metadata file itself must contain at least a name property, a description, and the runs property with a sub-property of using. And it's that property that tells the GitHub Actions platform what type of GitHub action we're going to be using. Now, in addition, it can also define things like inputs and outputs or names, as we've seen earlier. Now, the asterisk in this case is depending on the type of custom action that you're building, you may have additional required properties. As an example, in this case, I'm building a JavaScript-based custom action. So I've got the name property, that description, I've got the run using node 20, and because it's a JavaScript-based custom action, I'm also required to add in the main property, which simply tells the tells the GitHub Custom Actions platform that this is the file we need to call when bringing up this custom action. Now, a couple of quick warnings. When designating the runs using for Docker and Composite, you actually use the keywords Docker and Composite. For JavaScript, you designate the node version. GitHub Actions currently supports only two versions of Node, version 16 and version 20. In addition, if you're building a JavaScript-based custom action, you must commit your node modules to the repository or use something like Vercel's NCC package to bundle everything into a single file. If you're using a composite custom action, just be aware that those public runners that your action runs in may not have the versions of the binaries and programs in the OS that you need, and you may have to update those. If you get to the point where you're having to update almost all the binaries before you can do anything, that might be a good time to look into building a Docker container for your action to run in. So now let's build our first custom action. So if we come in here, all right, so first thing I'm going to do is I'm going to create the name because it has to have a name. So I'll say this is the welcome to the party action. And we're going to give it a description. Again, just welcome someone to our party. I'm going to define an input because I'm going to ingest some information. In this case, very similar to that workflow we did earlier. We're just going to get a name of somebody who to greet. I'm then going to do a composite-based custom action. So I've got runs and then that subproperty of using. So composite. I then have to have some steps in here because I'm building the composite action. In this case, I'll give it a name and an ID. And then my step will be to run hello, and then go back up to the inputs context and grab that who to greet. Now you'll also notice I've added a shell. So you can, in addition to an ID and then the run, you have the ability to designate the shell. So you can do bash or sh, PowerShell, or Python. In this case, again, I'm just doing a simple bash with an output. Now, remember earlier I mentioned we cannot run our action without a workflow. So I have to have an accompanying workflow in order to run this action. And I also forgot to mention that I've included this action file in a greet user directory. So here's my action metadata file inside a greet user directory. So it's in the root. I currently have this inside of an actions directory inside of .github. You don't have to put it there. It can be anywhere inside of your repository. It just makes sense in this case. So I have to have a workflow. So here's my workflow. So welcome a user via an action. Again, I'm doing the workflow dispatch. I've got some inputs just like earlier. Except this time, the first action that I do is a checkout. So by default in your workflows, the runner does not have access to the repository where the workflow lives. So the action checkout checks out the repository into the file system of the runner. Now that I actually have this repository in the runner, I can then say, okay, I want to use an action that's in the repository. So now I'm calling GitHub Actions, create user. Then I'm saying it has an input. So I use the with keyword. I then designate the ID and then pass it in the value. So in this case, we're going back up to the inputs, to the name, grabbing that value, and then sending that into the action we just built. So to see this in action, come back out to my actions tab, an action. I'll say run the workflow, who we're going to greet. So I'll say DjangCon again. So again, this is going to take this input from the workflow, call the action, and then send it into the action. There's my job. So there it's checking out the repository. There we go. So then it runs my action. That action then is to echo out from that input. All right. So we've talked about the GitHub Actions platform. We've talked about the different pieces of the GitHub Actions platform that we'll work with. We've talked about components of a workflow, that main workhorse where we do most of our automation, or building out of our automation. We built our first workflow. We talked about the components of a custom action, different places that we can store those actions, as well as the different types of actions and the pieces that are required for a custom action. We built our first custom action, as well as the accompanying workflow that has to go with an action. And along the way, I talked about the caveats and gotchas. The last piece I want to share with you is kind of putting it all together. How do we take all these pieces and parts that we've talked about and actually do something tangible, something we can actually utilize? So in this case, what I want to do is with a repository, when I create a PR, I want to automatically have an instance of my environment brought up with this new code, and then run a visual regression test against that PR code versus my production site. So I have whoops, I forgot to bring that up. So let's hit this real quick. So I have a production website, nothing too fancy here. And again, what I want to do is when I run a PR, I want to have a version of that site brought up. So this is where platform.sh comes back in. one of the nice things about our service is we have a GitHub integration. When you create a pull request, GitHub contacts us and sends us that pull request code. We then clone your production environment into its own self-contained containers with that new PR code. Once it's all brought up, we send the URL back to GitHub, which then presents it to you inside of your checks. So in this case, I can see that I now have a fully cloned version of my production website with this new PR code, and we add the PR number to the beginning of the URL. All right, so to see this to see this workflow inside of this site's code base, here I've got the event pull request target where I'm going to say, when we're asking to do a pull request into main, I want to run this job. In this case, I'm saying the first step is to use this other action. What that action does is simply asks GitHub, hey, has platform responded back with success? And if so, has it given you the URL? The output for that action is the URL. Then I can turn around and run my other action that I've built up to run the visual regression testing, passing in a test URL and a reference URL. Now, if you've never done visual regression testing before, what it does is allows you to take screenshots of a baseline site, in this case, my production URL, and then take screenshots of a testing version, in this case, my PR, and then run diffs. For this custom action, I'm using Backstop.js, which is a visual regression testing tool. And to kind of show you a quick example, here's a output of a backstop test instance. And I can see I had 24 passed and 1 failed. I can then go in and look at my reference site versus my testing site, and then look at the difference. In addition, run a scrubber across the two to be able to see where the difference is. And I can see in this case, everything below this image appears to be kind of bumping up just a little bit. Now the action itself that I'm accessing is going to be a composite-based action where I'm accepting 2 inputs because I'm going to be running, I need a baseline URL and a testing URL. So the first step in this composite action is simply to verify that what we were given for one of these URLs is a URL. So this action that I'm calling simply says, does this string look like a URL? And then does a curl on the URL to make sure the server is responding. So I do it once for the reference URL, once for the test URL. I then install Backstop into this file system. In addition, Backstop runs, it's based on a configuration file called backstop.json, where we designate the viewports and those media breakpoints, and then the URLs and locations that we want to test. So in doing so, I need to swap out those example URLs with the URLs we were just given. To do that, I was going to use JQ, but the version of JQ in the runner itself was a little out of date. So the next step in is to update JQ to 1.7. The next step after that is I simply, using JQ, swap out those URLs, and then I can then run my backstop reference. So it'll bring up my production URL and take screenshots. Once it's done, I then want to run the same thing, but against my testing. But Backstop will report a non-zero exit code if the tests fail. And as I mentioned earlier, steps are dependent on one another, and by default will fail if any command in that step fails, which I don't want to have happen. So in this case, I'm saying continue on error true. So even if this step fails, I want to keep going with my other steps. I'm running in bash, so I'm going to set E to make sure that none of these individual commands will fail the rest. So I'm running backstop test. I then grab the result from backstop test. Then if the test results were not successful, I'm going to set a variable. And then down below, I'm going to reset that variable as an output. Now, in this case, I'm setting it as an environmental variable, but we could also use GitHub outputs at this point. We'll skip this next step. This is about debugging, which I did not have time to cover today. The second to last step, then I say if what I set up above during that test failed, then I want to run this step. And in this case, I'm using an action called upload artifact. So I want to take the results of that test that it generated, those diffs. I want to save them and attach them back out to the run of this workflow. And the last is I want to return back the results from that test. So if it failed, I want to fail out this action or send a fail from this action back out to the workflow. So we can see this run. In this case, it did fail. So if I check out the details of this, I can see, oh, Vex.visual regression testing failed. Please see the generated report. I'll go look at the summary. Oops, scroll down. I can see it did, in fact, attach that artifact. I've already downloaded that, and I can show you the difference here. In this case, it looks like I had an image that failed to load. So between reference and test, I had an image that failed. Excuse me, cough. Almost made it the whole way without coughing. I'm very proud. All right. So unfortunately, because I'm not there, I don't have time for any questions. Hopefully my coworker is possibly there to answer any questions. I would love to talk to you about this. And I'm, again, very, very sorry I couldn't be there with you. But again, it was best to, because I was positive to stay away. This is my contact information. You can scan that QR code and reach out to me. You can find me on Linktree. There's my Linktree profile. Really, if you want to just search for my last name, Gilzow, there's only a handful of us in the United States, so you'll probably be able to track me down. And with that, I thank you very much.